This project builds a machine learning model to predict the net hourly electrical output of a combined cycle power plant. We're working with 9,568 hourly sensor readings, including ambient temperature, exhaust vacuum, ambient pressure, and relative humidity. Our target variable is PE, the net electrical power output in megawatts. Since PE is a continuous numeric value, this is a supervised regression problem, not a classification task. I used all for ambient sensor readings as features: temperature, exhaust vacuum, ambient pressure, and relative humidity. To evaluate performance, I chose RMSE, root mean squared error, measured in megawatts, because it penalizes large errors more heavily, which matters for grid load planning. I compared 3 types of algorithms: linear regression, polynomial regression to capture nonlinear relationships, and random forest, an ensemble method that can model complex feature interactions without manual engineering. Before comparing models, I split the data into 80% for training and 20% held out as a final test set, and touched until the very end. Within the training set, I used threefold cross-validation to fairly compare 5 candidate models to linear regressions with different feature sets, a degree to polynomial regression, and to random forest configurations with different hyperparameters. The random forest models clearly outperform the linear approaches, achieving a cross-validated RMSE around 3.5 megawatts, compared to over 4.5 megawatts for linear regression. Based on cross-validation results, I selected the random forest model with 150 trees and a max depth of 12 as my final model. This configuration had the lowest average validation RMSE with a small standard deviation, indicating stable, reliable performance across folds. Now for the real test. I evaluated the final model on the InTouch test set. It achieved an RMSE of 3.35 megawatts, a mean absolute error of 2.46 megawatts, and an R-squared of 0.961. This means the model explains 96% of the variance in power output, and on average, predictions are off by only about 2.5 megawatts out of a range spanning roughly 420 to 495 megawatts. For context, a naive baseline that always predicts the average output would have an RMSE of 17 megawatts, so this model reduces error by roughly 5 times. Looking at feature importance, ambient temperature is by far the most influential factor. A random forest model using all for ambient sensor readings predicts power plant output with high accuracy, explaining 96% of the variance with an average error under 3.5 megawatts. Thank you for watching.